Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. I am recording video after a few days because I was busy with some personal work. Anyway, so this is part 32 video on the chapter of mensuration. This is a chapter test number 1 where I have prepared 10 multiple choice questions based on the entire concept of area and perimeter from the chapter of mensuration. I will solve, this is the solution of the chapter test number 1 problems. The PDF of the problems will be, the link of the PDF will be there in the description below. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in the solution of chapter test number 1 on the chapter of mensuration. Okay, so on the left hand side I have the problems. There are 10 multiple choice questions. Ideally you should be able to solve this all the questions in 45 minutes, taking approximately 3 minutes to solve a question. I will always recommend you to try to solve the problems yourself first, and then of course see this solution video to understand how I am applying the concept to solve the problem. Maybe it is possible that my solution method will be better, or it may not be the fact that my solution will be better than yours, but please do watch this solution video. Okay, so let's start solving the problems. The problem one, there is a figure. It says ABCD is a square and 4 equal quadrants are drawn at each vertex of the square. If the area of each quadrant is A square units, then the perimeter of the square is. Okay, now the diagrams I will draw for each problems, it will be very approximate. Please do not consider them to be perfect. So this is the square ABCD. We have a square ABCD and we have the quadrants drawn at each corner of the square. So the quadrant at the corner or the vertex D is something like this, and the quadrant at the corner C is something like this, and the quadrant at at vertex A is something like this, and the quadrant at vertex B is something like this, and we have to find the area perimeter of the square. So let's say, okay, so let's say the each side of the length of each side of the square is x units. Is x units. What is given? The area of each quadrant is given. Now remember that all the quadrants are equal. It is given that 4 equal quadrants. Now if the 4 quadrants are equal, let's say I am giving some name to the quadrants. Let's say this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So all these 4 quadrants are equal, meaning their radius is same. Remember that a quadrant is a quarter of a circle. That is the central angle, a quadrant, the central angle is 90 degree. So this is a quadrant. This is a quadrant where these two are the radius of the circle. So this is meant by the quadrant. Now, so any quadrant is always, the area of any quadrant is always equal to 1/4 the area of the circle having the same radius. Okay. So now we have to understand what will be the radius of each of the quadrants. Remember that you can see that all the consider the quadrants Q1 and Q2. They are touching at a point on the side DC. Let's say this be the quadrants Q1 and Q2 will touch each other on the side DC, let's say at the point E. Similarly, Similarly, the quadrants Q1 and Q3 will touch each other on the side AD, let's say at the point F. Similarly, we will have the quadrant Q3 and Q4 will touch at the, let's say, point G, and quadrant Q2 and Q2 and Q4 will touch on the side BC at the point, let's say, H. So we will have, in this scenario, we will always have, since the quadrants are equal, the radius will be equal, and so we must have DE is equal to EC. This will also be equal to DF will be equal to AF. These are all will be the radius of the quadrants. Will be equal to AG, will be equal to GB, will be equal to CH, will be equal to HB. All these are equal, and they are the radius will be equal to the radius of the circle. Now clearly we can see that if DE is equal to EC, and we have considered the DC to be x, so all these radius of the quadrants will be x by 2, where x we have considered to be the length of each side of the square. Okay, so if so radius is x by 2, the radius of all the quadrants is x by 2. Now what is the area of the circle having radius x by 2? Area of circle of radius r of radius x area of the area of a circle with radius x by 2 is equal to, we know, pi into r square, radius square, that is x by 2 square. So this is equal to pi x square by 4. This is the area of a circle of radius x by 2. So what will be the area of each of these quadrants? So area of all the quadrants, they are equal. Since they are equal quadrants, they will be 1/4 the area of the circle of radius x by 2. So area of quadrant Q1 will be equal to Q2 will be equal to area of quadrant Q3 will be equal to area of quadrant Q4, and that will be equal to 1/4 of the area of the circle of radius x by 2, which is pi x square by 4. This is equal to pi x square by 16. Pi x square by 16. Okay. So area of each quadrant is pi x square by 16, where we have assumed x to be the length of each side of the square, but the area of each quadrant is given to be a. So we can say this implies that pi x square by 16 is equal to a. So this implies that x square will be equal to 16 by pi a. Okay, we have to find the perimeter of the square, which will be 4x. So we need to find x. So this implies x is equal to square root of 16a by pi. This will be 4 into square root of a by pi. Okay, now okay, so this implies perimeter of the square ABCD will be equal to 4x. This is equal to 4 multiplied by 4 square root of a by pi. This is equal to 16 multiplied by square root of a by pi. So this is the perimeter of the square. So the correct choice is D. D is the correct choice. Now if I am making any kind of calculation mistake or applying concepts incorrectly and coming up with incorrect solution, then please feel free to let me know in the comment section. I will highly appreciate that. Okay, let's do problem number 2. Question number 2. So we have a figure. O is the center of the circle of radius r. Okay, A and B are points on the circumference of the circle such that angle AOB is the angle AOB, which is denoted by theta, is equal to 120 degree, and AB, that is AB is a chord of the circle. The length of the segment AB is 2 by 3 r, where small r is the radius of the circle. Then the area of the shaded region is. Okay. Let's quickly draw the diagram. We have the circle. So let's say this is the center O, and we have, this is radius, this is point B on the circumference, this is point A on the circumference. We have AO is equal to the radius, also OB is equal to the radius, and this angle theta is given to be 120 degree, and AB, so we have to join AB, the length of AB is given to be 2 by 3 r. We have to find the area of the shaded region. Okay, so let's say area, okay, so let's mark the shaded region to be R2, and the triangle AOB as R, no, let's say we name the shaded region to be R, only R, not R2, R. So we have to find the area of the region R. Okay, now, okay, so how can we find the shaded area of the shaded region? You see that we see a sector. So AOB, let's say we consider another point on the circumference in between A and B. Let's say this be C. So we have the sector. Let's say we have the sector OACB. This sector is having a radius of R and the central angle of 120 degree. So okay, now let's let we give the name, let OACB be the sector with central angle. Central angle means a sector, the arc, the angle that the arc makes at the center of the circle, that is known as the central angle. Central angle of theta is equal to 120 degree. So we are giving a name of the OACB to the sector that is made where the arc is ACB and which is making a central angle of theta. Okay, now clearly we can see that area of the triangle AOB plus area of the shaded region, which we have named as R, is equal to area of the sector OACB. We clearly see this. Area of the triangle AOB plus area of the shaded region R is equal to area of the sector OACB. Now, to find the area of the shaded region R, we need to know area of the triangle AOB and the area of the sector OACB, which we can find. Let's quickly find what is the area of triangle AOB. Now, how can we find? Okay, so we need to find the area of the triangle AOB. We know that the triangle AOB is an isosceles triangle because AO is equal to OB is an isosceles triangle, and we also the length of AB is a base. So if I consider, if I draw the triangle AOB, let's say this is the triangle OAB. So AB is this length is given to be 2 by 3 r, and this is equal to r and r. So to find the area of this triangle AOB, we know the base AB, and we know that if we draw, since this is an isosceles triangle where AO is equal to OB, if I draw a perpendicular from the vertex O on AB, then this point, let's say this point be E, E will be the midpoint of AB, which means E will be the midpoint of AB, which means that AE will be equal to EB will be equal to half of 2/3 R. 2/3 R is the length of AB. It's half, which is equal to R by 3. So AE will be equal to EB will be equal to R by 3. Now I need AE OE in this triangle OAB OE is the height. OE is the height corresponding to the base AB. If I can find height H, then I can find the area of this triangle OAB using the formula half base into height. So how can we find the length of OE, that is height? We can find it using the Pythagoras theorem. We will have in triangle AOE, we will have hypotenuse, we will have AO square is equal to OE square plus AE square. So this implies, what is AO? AO is R. So we have R square is equal to OE. OE is the height, H square, plus AE. What is AE? AE is R by 3 square. So this implies H square is equal to, I am trying to find the height H. So H square will be equal to R square minus R by 3 square is R square by 9, which is equal to 8R square by 9. So this implies H will be square root of 8R square by 9, which is equal to 2 root 2 by 3R. Okay, so H we have found. Okay, so now we can say that the area of triangle AOB will be equal to half the base, that is AB, half AB multiplied by H. This is equal to half. AB was given to be 2 by 3 R, and height H we have found to be 2 square root of 2 divided by 3 multiplied by R. If I simplify this, it becomes 2 square root of 2 by 9 R square. This is the area of the triangle AOB. Okay, now to find the area of the shaded region R, we need the area of the triangle AOB and the area of the sector OACB. Now what is the area of sector OACB? We know the formula to find the area of a sector. So area of sector AOCB is, we know the formula is theta by 360. Theta is the central angle, that is central angle of the sector, multiplied by pi R square, pi R square, where R is the radius of the sector. This is the area. Pi by theta by 360 multiplied by pi R square is the area of a sector, area of the sector AOCB. Okay, now theta is given to be 120 degree. So we have 120 divided by 360 multiplied by pi R square. This will be equal to 3. Okay, so pi R square by 3, pi R square by 3 is the area of the sector AOCB. So now we can say that area of the shaded region R will be equal to area of the sector AOCB minus area of the triangle AOB, which will be equal to pi R square by 3, pi R square by 3 minus area of the triangle AOB was 2 square root of 2 by 9 R square. Now I have to simplify this and see how we can simplify this so that it matches with one of the given choices. Now, okay, first of all, let me take R square by 9 as common. R square by 9 as common if I take, then I have here 3 pi minus 2 square root of 2. Do we have this as a choice? R square by 9, choice A is R square, no. choice D is r square by 9 3 pi by minus 2 square root of 2. Okay, so the correct choice is D. D is the correct choice. Okay, let's see the next problem. Question number 3. The ratio of the diagonal of a square and height of an equilateral triangle, both having equal areas, is. The ratio of the diagonal of a square and height of an equilateral triangle. We have to find the ratio of the diagonal of a square and the height of an equilateral triangle where the area of the square and area of the triangle is equal. Okay, so let's roughly draw a square. Let's say the square is having all sides x. Okay, and let's say the diagonal is D. Okay, an equilateral triangle. Okay, so we have, let's say this is an equilateral triangle where let's say all the sides are of length A. Okay, fine. We have to find the ratio of the diagonal. Okay, the diagonal of the square and height of the equilateral triangle, where it is given that area of these two figures are same. So let's say the area, let's say area, let's give some name to the squares. Let's say I am giving the name S to the square and T to the triangle. So we have area S is equal to area T. This is given. Let's assume the area. Let's say let's say the area be A. Okay. Now for the square, we must have area A should be equal to, we know that the area, what is the relation between the area and the diagonal of a square? Area of a square is equal to D square by 4, where D is the diagonal of the square. So basically we need not need the length of the square. Okay, so if D is the diagonal of the square, we must have its area is equal to D square by 4. Okay, from here we can say that D square is equal to 4a. This implies D diagonal is equal to square root of 4a, which is equal to 2 square root of a. Okay, now for the triangle, we know that for an equilateral triangle of where the length of each side is a, we know the area A is equal to square root of 3 divided by 4 a square. Okay, so from here we have to find the height of the equilateral triangle. Okay, so from here we can say a square is equal to 4a by square root of 3. Okay, this implies that a is equal to square root of 4a by square root of 3. Now this is equal to square root of 4a divided by square root of, and then inside square root of 3. This is equal to 2 square root of a divided by square root of 3. This is a. Now we also know what will be the height of an equilateral triangle, the relation between the height of an equilateral triangle and the length of each side. If I consider the height of the equilateral triangle to be h, I know that height h will be equal to square root of 3 by 2a. So this is equal to square root of 3 by 2. A is 2 into square root of a divided by square root of 3. Okay, so 2 cancels out and this becomes okay. So what is square root of 3? I can say that square root of 3, so square root of 3, I can say this to be square root of 3 whole square, and I have square root of a divided by square root of 3. This is equal to, I can cancel, I can divide, so if I So this, if after simplification, this will be square root of 3 multiplied by square root of a. Okay. So I have found the diagonal of the square. I am assuming both the square and the triangle to have the area A, capital A. I have found the diagonal of the square to be 2 into square root of A, and the height of the equilateral triangle to be square root of 3 multiplied by square root of A. So now the problem has asked the ratio between the diagonal and height. So D by H will be equal to square root of 2. What was D? D was 2 square root of A. Okay. So D is 2 square root of A, and then divided by square root of 3 multiplied by square root of A. So square root of A cancels out. This is equal to 2 by square root of 3, square root of 3. So this implies that D is to H is equal to 2 is to square root of 3. So the correct choice is B. B is the correct choice. B is the correct choice. Okay, let's do question number 4. "36 unit squares are joined to form a rectangle with the least perimeter. The perimeter of the rectangle is..." 36 unit squares are joined to form a rectangle with the least perimeter. Now, when 36 unit squares are joined, we don't know how it is joined. Let's say this be 36 unit. Just for the example, just for the sake of discussion, let this be 36 square units square. Now I can unit square. Sorry, this is, let's say this be a unit square, that is a square of each side 1 unit. So it will have one. So its area will be 1 unit square. So this so 36 number of these unit squares are joined. Now we don't know how many of these squares will be across the length or across the breadth. So we don't know when it is joined to form a rectangle. We don't know what will be the length and breadth. But whatever be the length and breadth, the perimeter has to be least. The perimeter has to be least, but also the area of the rectangle will be equal to 36 square units, because after all we are joining 36 number of unit squares. Okay, so area of 36 unit squares is equal to 36 square units. So this implies area of rectangle form will also be equal to 36 square units. Now we have to find the perimeter of the rectangle so that it is least. We have to choose the length and the breadth in such a way such that length and breadth of the rectangle in such a way that the area will be 36 units, but the perimeter will be least. Okay, that is, let L and B be length and breadth of rectangle. So this implies we must we must have L into B. Area is 36. Perimeter has to be least. Perimeter is 2 into L plus B, 2 into length plus breadth. Now so the task is, now we know that L into B is 36, and we have to choose L and B in such a way such that 2 into L plus B is minimum. Now if L okay, so is minimum. Okay, now first of all, we can it is you must understand that 2 to make P minimum, what we have to make is we have to choose L and B in such a way such that L into B becomes 36 and L plus B is minimum. Perimeter is 2 into length plus breadth. You cannot, 2 is, we have a factor of 2, so we cannot change 2. So all we can do to make the perimeter minimum, we must make L plus B minimum. So P minimum implies L plus B is minimum. L plus B is minimum. So how can we now choose L and B such that L plus B is minimum and L into B is 36? Okay, so now let's see how we can choose L and B. That is, we have to factorize 36. We have to see, we have to make two factors of 36 and see and which factor in which two factors the sum of which two factors is least. So 36, if I factorize into two factors, I can factorize, I can do the factorization as 9 multiplied by 4. This can be one factor, or I can factorize it as 12 multiplied by 3. I can also factorize this as 18 multiplied by 2. I can factorize it as 36 multiplied by 1. So these are all the possible factors of 2. These are all the possible factorization of 36 as a having two factors. Now we have to see of all these choices, the sum of the two factors is minimum. Now for R, 9 into 4, 9 plus 4 is equal to 13. For 12 into 3, 12 plus 3 is equal to 15. And for 18 into 2, their sum is 20. And for 36 into 1, their sum is 37. Clearly, 13 is the minimum. Clearly, 13 is the minimum. So definitely the length has to be L 9 and breadth has to be 4. So length will be 9 and breadth will be 4. So this implies perimeter minimum. This means minimum perimeter is 2 into length plus breadth. This is equal to 2 into 13, which is equal to 26. So 26 units. 26 units is the minimum perimeter, and hence the correct choice is C. C is the correct choice. Okay, let's do question number 5. A circular disc of area A square units requires X revolutions to roll from point P to the point Q on the floor. Then the distance between the points P and Q is. A circular disc of area A square units requires, let's say this be the circular disc of area. The area of the circular disc is A. So it is rolling from point P to the point Q. So basically, let's say this be, so there is a floor. Let's say this this is the floor, this be the point P, and let's say from the point P the disc is moving to the point Q, and it requires X revolutions. Okay, so in X revolutions, the distance covered by the disc is PQ. We have to find the distance PQ where the area of the disc is given to be A. Now we know that. So what will be the, first of all, let's say the area of the disc, the radius of the disc be R. Okay, now so circumference of the disc is 2 pi r. We know that in one revolution in one revolution, disk covers a distance, the distance covered in one revolution of the disk is equal to the circumference of the disk, which is 2 pi r. So in the problem it is given that the disk is rolling and it is going from point P to Q in x revolutions. So in x revolutions, disk covers distance which is equal to, using unitary method, 2 pi r into x, which is 2 pi r x, this much distance. Okay. Okay. So this implies definitely PQ, the distance covered PQ has to be equal to 2 pi rx. Now we have to find r. We don't know r, but area of the disk is given, which is A, and from there we can easily find r. Now area of the disk is pi r square. So this implies r square is equal to A by pi. This implies r is equal to square root of A by pi. So this implies now the distance covered PQ is equal to 2 pi x multiplied by r, which is square root of A by pi. This is equal to 2 pi x multiplied by square root of A divided by square root of pi. So square root of pi will divide pi with square root of pi. So this becomes 2 into square root of pi multiplied by x multiplied by square root of A. This is equal to 2x multiplied by pi a. 2x multiplied by square root of pi a. This should be the distance PQ. So the correct choice is C. C is the correct choice. Okay, let's see question number 6. Question number 6. So we have a diagram. So three identical circles of radius r touch each other at the points D, E, F, having centers at the points A, B and C. Find the area of the shaded region. Find the area of the shaded region. Okay. So let's quickly draw the diagram. So this is the circle. There are three identical circles. Let's quickly, so this is, okay, and then we have the three circles are touching like this. Okay, so the centers of the circles are A, B and C, and they are touching at the point. Okay, so the circle with centers A and B, if we join the centers A and B, it will pass the line segment AB will also pass through the point at which the two circles are touching. So if this point is D, then ADB are collinear. ADB are collinear. Similarly, this point is E, so AEC is collinear and AEC is collinear, and if this point is F, then BFC is collinear. Okay, we have to find the area of the shaded region, this region, area of this region. Okay, now first of all, since all the three circles are touching each other and they are of equal circles, meaning identical circles means they are of having same radius, which is given to be r. So this is r, this is r, this is r, this is r. Now, so we can say that AD is equal to DB is equal to r. Also, we have AE is equal to EC is equal to r. Also, we have BF is equal to FC is equal to R. Now, since AEC, the points AEC are collinear, the points ADB are collinear, the points BFC are collinear, we can say that in triangle ACB, we clearly see that AB is equal to twice AD, which is equal to twice R. Similarly, AC is equal to twice AE, which is also equal to twice R, and we have BC is equal to twice BF, which is equal to twice R. So the triangle ACB is an equilateral triangle having the side length of twice R. Okay. Now, also see that we are having three sectors inside the triangle. We are having three sectors which are formed at every vertex of the triangle ABC. So these are the angle, the central angle of the sectors are the angles of the triangle ABC. Now, since the triangle ABC is an equilateral triangle, each angle will be equal to 60 degree. So if I consider all these angles to be theta, the angles of the theta, this is also theta, we have theta is equal to 60 degree, since the triangle ACB is an equilateral triangle. Okay. Now, so at every corner of the triangle ABC, at every vertex of the triangle ABC, we see a sector with the radius, a sector of radius R, small r, and central angle of 60 degree. So I can say that area of sector, let's say AED, will be equal to area of sector DBF will be equal to area of sector CEF. And what will be the area of all these three identical sectors? It will be equal to theta by 360, where theta is the central angle of the central angle of all these three sectors, which is equal to 60 degree, multiplied by pi r square. Pi r square. Now, okay, pi r square. This is equal to 60 by 360 pi r square, which is equal to pi r square by 6. Okay. So area, so then the area of each of the three sectors is pi r squared by 3. So area of all three identical, by identical because they all have the radius r and they all have the same central angle of 60 degree. Area of all three identical sectors will be equal to 3 multiplied by pi r squared by 6, which is equal to pi r square by 2. Okay. Now, what will be the area of the shaded region? The area of the shaded region is nothing but the area of the triangle ABC minus the area of all the three sectors. So let's quickly find out what is the area of the triangle ABC. Now, triangle ABC is an equilateral triangle having the length of each side to be equal to twice r. So we know the formula for the area of an equilateral triangle. It is square root of 3 divided by 4 multiplied by side square. In this case, the side is twice r. This is equal to square root of 3 multiplied by 4r square by 4, which is equal to square root of 3 r square. Okay. Now, okay. So, what will be the area of the shaded region? Area of shaded region will be equal to the area of the triangle ABC, which is square root of 3 multiplied by r square minus the area of all the three identical sectors, which is equal to pi r square by 2. Pi r square by 2. If I take r square common, I have r square multiplied by square root of 3 minus pi by 2. This should be the area of the shaded region. Now, maybe we have to simplify this. Okay, so we already have a choice. So the correct choice is B. B is the correct choice. Okay, let's see question number 7. Question number 7. The perimeter of a room is P units and area of its four walls is A square units. If the height of the room is half the length means the length of the floor of the room, then the area of the floor of the room in square units is, okay, perimeter of the room is P. So we know, if we consider L and B to be the length and breadth of the height, so let L is equal to length, let length is equal to L, breadth, that is the length of the room, be equal to L, breadth be equal to B, and height be equal to H of the room. Okay, so what is given? The perimeter P is equal to 2 into length plus breadth. P is given, okay, and what area of the four walls is given, which is A square units. We know, so we must have A, area of the four walls of a room. The formula is 2 into length plus breadth multiplied by H. Now 2 into length plus breadth is nothing but perimeter. So the area of the four walls of a room is nothing but perimeter, that is the perimeter of the floor multiplied by H. So from here we can find H is A by P. So we know the height of the room is A by P. Please note that in this problem only A and P are given, where A is the area of the four walls of the room and P is the perimeter of the floor. So we have to find the area of the floor of the room, which means we have to find L into B. Okay. What else is given? It is also given that the height of the room is half the length. Height of the room is half the length. So this must be equal to L by 2. Height is given to be half the length. So H, which is equal to A by P, must be equal to L by 2. So from here we can say L is equal to twice A by P. Now we know H, which is A by P. We know L, which is twice A by P. We also know P. We can easily find then B. So this implies what is B? What is B? Now B, from here P equals to 2 into length plus breadth. From here we can say B will be P by 2 minus L. P by 2 minus L. Okay. Now what is L? L is twice A by P. If I simplify this, this will be P square minus 4A by twice P. This is this implies, oh sorry, this will be actually I'm trying to find out what is breadth. So this implies B, breadth will be equal to P by 2 minus L, which is equal to P by 2 minus twice A by P. Okay. So we have found, we know L and B. Now we can easily find the area of the floor. Area floor is nothing but L into B. What is L? L is twice A by P. L we have found to be twice A by P. And what is B? Breadth. Breadth we have just found to be P square minus 4A divided by 2P. So if I simplify this, 2 cancels out. This becomes A multiplied by P square minus 4A divided by P square. This should be the area of the floor. We have to see which choice is matching. Okay, so clearly the correct choice is B. B is the correct choice. A multiplied by P square minus 4A divided by P square. Okay, let's see the question number 8. If the diameter of a circle is equal to the diagonal of a square, then the ratio of their areas is, we have, let's say, the circle, let's say this be the center, so this must be, let's say, a diameter, this is diameter. Okay, if the diameter of a circle is equal to the diagonal of a square, okay, so let's say d is small d is the diameter of this circle, and let's say we have the square whose diagonal is also d. We have to find the ratio of the circle and the ratio of the areas of the circle and the square. Okay, area. So how do we find the area of a circle when its diameter is given? We know that area is equal to d square by 4. D square by 4, where d is the diameter of a circle, is the formula for area. D square by, no, I think I am doing something wrong. Area of a circle is pi r square. Pi r square is the area of a circle. And what is r? R is nothing but d by 2. The radius of a circle is equal to diameter by 2. So this becomes pi d square by 4. Okay, so the area of the circle is pi d square by 4, where d is the diameter of the circle. Okay, sorry, so this will be pi. Area of a circle is equal to pi d square by 4, where d is the diameter of the circle. And for the square, the diagonal is d. To find its area, so what is the relation between the area and the diagonal of a square? We know, I have forgot the formula. I know that diagonal of a square is equal to square root of 2 multiplied by the length of each side, a. If a is the length of each side of the square, then the relation between diagonal d and a is d is equal to square root of 2 by square root of 2 multiplied by a. Okay, now this implies that a is equal to d by square root of 2. Now what is area of the square of side a? Is nothing but a square. So this should be equal to d by square root of 2 whole square, which is equal to d square by 2. So the area of a square having diagonal d is equal to d square by 2. So now let's say the a1 be the area of the square and a2 be the area of the a1 be the area of the circle and a2 be the area of the square. So we have to find a1 by a2. a1 by a2 is equal to pi d square by 4, this whole divided by d square by 2, d square by 2. Okay, if I simplify this, this becomes pi d square by 4 multiplied by 2 by d square. D square cancels out and we have 2. So this is equal to pi by 2. Now which is equal to pi is 22 by 7, and this is multiplied by 1 by 2. This becomes 11 by 7. Okay, so this implies that A1 is to A2 is equal to 11 is to 7. So the correct choice is C. C is the correct choice. Let's do the next problem. Question number 9. The inner dimensions of a hall are 40 feet by 20 feet and 30 feet. That is, length is 40 feet, breadth is 20 feet and height is 30 feet. The hall contains two doors of size 5 feet multiplied by 5 feet length and 10 feet breadth. Okay, and 4 windows of size 5 feet by 5 feet each. If the inner walls of the hall are to be fixed by tiles of size 1 feet by 1 feet, then find the number of tiles required. Okay, so basically we have to find the area, the effective area of the 4 walls, that is the area of the 4 walls excluding the area of the 2 doors and 4 windows. Okay, so area, let's find out area of one door. Area of one door is equal to the dimensions of the doors are 5 feet by 10 feet. So it will be 5 multiplied by 10 feet square, which is equal to 50 feet square is the area of each door. Okay, what is the area of a window? One window. The dimension of each window is 5 feet by 5 feet. So this is 5 multiplied by 5 feet square, which is equal to 25 feet square. Okay, so this implies area of 2 doors plus 4 windows is equal to, let's say this area be equal to A2 is equal to 50 plus 25 this much feet square, which is equal to 75 feet square. This is the area of the 2 doors and 4 windows. Sorry, I'm wrong. The area of 2 doors and 4 windows will be 2 multiplied by 50 feet square plus 4 multiplied by 25 feet square. This is equal to 100 feet square plus 100 feet square, which is equal to 200 feet square is the total area of 2 doors and 4 windows. Okay, now what is the area of the 4 walls? Area 4 walls of the room, total area of the 4 walls of the room is equal to, we know, 2 into length plus breadth multiplied by height, where L is the length of the room, B is the so L, B, H are the dimension of the room, that is L is length, B is breadth and H is height. The dimension of the hall, is given, so this will be 2 into length is given as 40 feet, breadth is given as 20 feet and height is given as 30 feet. So this much feet square is the area of the 4 walls of the hall. This becomes 40 plus 20 60, 120 multiplied by 30 feet square, which is equal to 3600 feet square. Okay, so now this implies effective area of 4 walls that need to be fixed, will be equal to the area of the 4 walls 3600 minus the area of the 2 doors and 4 windows, which was 200. This is equal to 3400 feet square. So now the problem is asking if how many tiles, where the dimension of each tile is 1 feet by 1 feet, how many tiles will be required to fix the wall, the effective area of the 4 walls, which is 3400 feet square. So clearly we can say this implies number of tiles required is equal to, will be equal to the total area, the total effective area of the 4 walls that need to be fixed, which is 3400, divided by area of each tile, which is 1 into 1, which is 1. The dimension of the tile is 1 feet by 1 feet, so area is 1 feet square. So this is 1. So this is equal to 3400. So 3400 tiles will be required, and hence the correct choice is D. D is the correct choice. Okay, let's do the last problem, question number 10. The side of a square metal sheet is 7 meter. A circular sheet of maximum radius is cut and removed. Find the area of the circular sheet. Okay, so we have a square sheet. Is considered to be a square. Okay, so this is the square, 7 meter. The length of each side of the square sheet is 7 meter. Okay, now the largest circle that can be the largest circular sheet that can be cut from this square sheet is nothing but the largest circle that can be drawn that can be inscribed or drawn inside the square, which will be the circle whose diameter will be equal to the side of the square. So this is the center of the circle. So the largest square that can be inscribed in the largest circle that can be inscribed in a square has a diameter equal to the side length of the square. So if I consider R to be the radius of the circle, that is the circular sheet, I must have twice R, that is the diameter of the circle will be equal to 7 meter. So this implies R, the radius of the circular sheet, will be 7 by 2 meter. The question is asked, find the area of the circular sheet. So the area will be equal to pi r square, this pi r square. So this is pi is 22 by 7 and r is 7 by 2 square, this much meter square. But the question has asked to find the area of the circular sheet in feet square, but remember that the length of each side of the square sheet is given in meter. Okay, so this is equal to 22 by 7 multiplied by 7 into 7 divided by 4, this much meter square, and this is equal to 77 by 2 meter square. Now we have to convert this meter square into feet square. Meter square into feet square. Now what is the conversion formula? How do I convert meter square into feet square? Find the area of circular sheet in feet square. 49 pi. If I look at the choices, it seems okay. So pi r square is 22 by 7. Okay, let me. You have to find the solution based on the given choices. So I have this area of the circular sheet will be pi r square. Okay, so this is equal to pi. We need not put the value of pi as 22 by 7 because pi is already there in all the given choices. Now what is r? R is 7 by 2 square, this much meter square, and this is equal to 7 by 2 whole square is 49 by 4. So this is equal to 49 by 4 pi. 49 by 4 pi, and this is in meter square, but I don't know why the question has asked to find the area of the circular sheet in feet square. I think there is a problem in the question. It should be in meter square, in meter square. So the area of the circular sheet is 49 pi by 4 meter square, and hence the correct choice should be C. C is the correct choice. So with this, it brings to an end in solving the 10 problems of chapter test number 1 on the chapter of mensuration. I will make another test, that is chapter test number 2, with more of these kind of problems from the chapter of mensuration. I hope solving these problems will give you a good evaluation of your understanding of the concept of area and perimeter from the chapter of mensuration. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So please stay tuned for the next video of where I will solve chapter test number 2. So thanks for watching, and until the next video, take care and bye.